Yeah, my screen is visible. Yeah. Okay. I'll start the. So we'll start the basic data types. So what are the basic data types in Verilog? Basic data types in Verilog. Basic data types in Verilog. So here, so data type is nothing but how you are so what is a data type? Okay, so how you are declaring your variable. So in the C language also we have the data types like int, char, float, or like that. So how you are declaring the variable, that is nothing but data type. Okay. So in this basic data type, one is first one is net data type. Net data type. So net data type. So this net data type is so basically it will be represent the physical connection only. Okay. So this net data type represents only the physical connection. Okay. So represent the physical connection. What is the physical connection is there? Okay. So this is physical connection. So where you are using this net data type means net data types are used to drive the values continuously from the driver. Okay, so I'll write here. It will use it to so it will use it to drive the value continuously, drive the value continuously from the driver. Okay, from the driver. Okay, so main important thing is this net data types, mainly these are not for storing the values. Okay, so these are not used for storing the values. Okay, so these are not for storing the values. Okay, so mainly you want to drive that any value. For that purpose you are using this net data type. Okay, so net data type. So again in net data type you have three types are there. One is wire data type. So mostly we'll use this wire data type, and war data type, and next one is WAN data type. WAN data type, wide data type, WAD data type, and WAN data type. Okay. Suppose example in the Verilog, suppose I'm writing a sample snippet, module example, wire. I'll write wire A. Okay, wire A and end module, wire A and end module. Okay, so wire A, this is wire A. So this is nothing but my variable. Okay, so this is nothing but my variable, or it is identifier. It is nothing but identifier, and this is nothing but data type. So this is a keyword only. Okay, this wire is a keyword. Okay, so in Verilog last class I told you around 150 keywords are there. So in this is one data type, and this is a keyword. Okay, so we can't use anywhere. So this is a wide data type. Okay, so where you are using this as a net data type means net data type. Suppose you have module A. Let us take this is module A, and next one is module B. Module B. So module A and module B. So if you want to connect this module A to module B, okay. So that means we need to drive some value to this through this module A to module B. Okay, this will drive some value. Okay, from this line, the module we will receive. Okay, so in order to communicate like this, you are using net data type. You are using net data type. Okay, so this is about the net data type. So this is so main thing you need to you need to remember about the net data type means for driving some values we are using net data type. So these are not used for any storing any value. Okay, mainly for driving the value we are using. Okay, so like that this is net data type. Okay, and so what is the default value? What is the default value? So default value. So if you consider net or wire data type, so here suppose So value set, I told you, no, the value set means so Verilog will support four state data type, that is 0, 1, four state value set, 0, 1, x, z. Okay. So what is the default value for wire data type? Okay. The default value for wire data type, suppose this is one of the interview question they will ask, wire A. Okay. If I consider wire A, what is the default value? Okay. So default value is Z. Default value is Z. Okay. So Z means what? This is high impedance. This is high impedance. Last class we already seen Z, high impedance, or it is not connected. Just open circuit. Okay. This is nothing but not connected. Okay. So this is about the net data type. And suppose if I consider one module example, let us take module example. I am using wire A. I am using assign A equal to 0. Okay, A equal to 0, and I am using assign A equal to 1. A equal to 1, and dollar display. I am using a system task dollar display. I want to display this value of A is percentage D comma A, comma A. Okay, and end module. Okay, so can you guess what is the value of A after executing this code? Can you respond? Hello, am I audible?
One.
uh, Value of A is 1 now. How you are telling value of A is 1? First,
It's continuously driving, right? So
A will be assigned to 0, and after that I am assigning A equal to 1. I am assigning A equal to 1.
yeah.
Hmm. I am assigning A equal to 1. Yeah. So in the first class, I told you Verilog is a sequential language. So Verilog is a concurrent language. Okay. So that means what is the difference between high level language and this HDL is Verilog is concurrent language. Concurrent. Okay. So this is Verilog is a concurrent language, and whereas C++ is a sequential language. Okay. Every instruction C or C++, this is sequential language. Okay. Sequential language means every instruction will be executed parallelly. Okay. That is nothing but sequential language. Okay. So that means here these both instructions will be executed parallelly. Okay. So that means the compiler will throw this value, that is A equal to X. Why? Because the compiler can't decide. First I assign the A value as 0. After that I assign A value equal to 1. Okay. Compiler can't decide either A equal to 0 or 1. Okay. So compiler will execute that A equal to what? X. Okay. So A equal to X. Okay. So this program you can try in the Vivado tool. So that you will get assign A equal to 0, assign A equal to 1, you are getting A equal to X. Okay. Like this you will get. Okay. And so here for getting the value, what you need to do? You need to use so for getting that value, you need to use var data type. Okay, var data type. Var means what? The name itself it is there. Or operation. Okay, so same program I'm writing. Example, Module example or module test. I'm declaring var m. Okay, var m assign m equal to what? 0, assign m equal to 1. Okay, assign m equal to 1, and so end module. Okay, so end module. So here what happens here? So var I declared, no? So var means what? Or operation. It will do the or operation. So that means so if I do the dollar display, So dollar display, I want to display this value. Okay. So the value of a is percentage d comma a. So when I display, so it will do the or operation. Okay. So that means 0 or of 1 means it will display 1. The output will be displayed 1. Okay. So output, so what is the value of m, what is the output, output m equal to 1 you will get. Okay, m equal to 1. Okay, so this is about var, and similarly wand also. Okay, so for the same program I am using wand data type. Okay, I am assign wand m equal to 0 and assign m equal to 1, m equal to 1. Okay, so it will do AND operation 0 AND of 1. So that means 0 AND of 1 means 0 AND of 1 means it will give uh, uh, so it will give AND means what, so m equal to 0, m equal to 0. Okay, is it fine? Net data type, what is the difference between wire, var and WAND? Shall I move forward?
Yes.
Okay, yeah. So next is reg data type. Reg data type. So reg data type, this reg data type, so we can able to store the data. For using the reg data type, we can able to store the data. Okay, we can able to store the data. Suppose like module example. Okay, module example, I am considering regex. Okay, regex, and I am using initial a equal to 0, a equal to 0. Okay, so and end module, end module. So I declared this reg now. So I declared this reg means the a value will be stored with, so it will store. So the a value, so for storing this 0 value into the variable a. Okay, so what is this means, storing 0 value 0 in variable a. Okay, so that means here when you are using this reg, we need to use in the procedural blocks. Either we need to use in the like initial block, or we need to use in the always block. Okay, so when you are using wire data type, you need to use a continuous assignment statement, that is assign, that you need to remember. Okay, and next, what is the default value for reg data type? Default value, default value for reg data type. Okay, default value for reg data type is x, don't care. Default value for reg data type is don't care. Okay, so that is the thing. And one more thing about the wire data type. Suppose if I consider wire a, so what is the size of a, what is the size or what is the width of a? Width of a is what? Can you guess what is the width of a? Width of a is 1 bit. Width of a is 1 bit. Okay, suppose if you consider a equal to 0 or a equal to 1. Okay, so this is nothing but 1 bit. This is nothing but 1 bit only. Okay, normally this RHS is how many bit means, last class we already discussed. This right side is 32 bit. 32 bit. Okay, so that means here what happens, so inside it will store 0 0 up to so on 0, it will store. Okay, so but whatever the LSB bit is there, that will be stored. Okay, a equal to 1 means 0 0 up to so on 1. Okay, 1 will be stored, but whatever the LSB bit is there, that will be stored into a. Okay, so that you need to know. And so similarly for the reg also. So suppose reg a, if we consider, so this is a is how many bit? This is 1 bit only. This is 1 bit only. Okay, reg is a 1 bit. And one more thing, like if you consider reg a initial and a equal to, if I consider 32. Okay, So 32 means it will be converted into binary, and whatever the LSB, least significant bit, that is A equal to 0. So you will get, if you convert into binary, you will get a LSB as 0 only. So that 0 LSB bit will be stored into A. Okay. And one more point, this wire and reg data types are unsigned data types. Unsigned data types. Unsigned data types means if you give the signed number, okay, if you give the negative numbers, it will store in terms of positive only. Okay, so these are nothing but unsigned data types. Is it fine? Any doubts or queries? Shall I move forward? Hello.
yeah, you can move
Yeah,
forward.
yeah, yeah. So next is this is about the Y data type and rich data type, and next is vectors. Okay, so vectors are nothing but what, this is are nothing but grouping the multiple bits in a single bit. Okay, so as we discussed that Y data type, wire A, reg A, these are nothing but single bit only, it will show a single bit of value. Sometimes I want to, I want to design for mux. Okay, so a mux have if you consider 2 cross 1 mux, it consists of two inputs and one selection line and one output. There I naught and I1 is there. So two inputs are there. So I want to declare with one variable. So there I can use vectors also. Similarly 4 cross 1 mux. So I can use vectors also. Decoders, encoders. When you write the Verilog code for this decoders, encoders, and ripple carry adder also. Ripple carry adder, you have four inputs are there, no? So A0, A1, A2, A3, and B0, B1, B2, B3. There we can represent the inputs. We can declare inputs in terms of vectors. Okay. So that means grouping of bits into single. What is a vector? Grouping of bits into single. Okay. This is nothing but a vector. Okay. So what is the syntax for this vector? Syntax is data type, data type, and next range, and next variable. Data type, range, and variable. Okay, so data type can be what type of data type? Reg or net data type. Okay, reg or you can use a reg data type or wire data type. And range is two types of representations are there: MSB down to LSB. Okay, MSB, this is down, MSB down to LSB, or LSB to MSB. This is nothing but LSB to MSB. Okay. So this is nothing but so normally big endian, and this is nothing but little endian. Okay. So mostly this will little endian. Mostly this will not prefer. This only will prefer. Okay. Big endian will prefer. First MSB will come and next LSB will come. Okay. So this is nothing but MSB down to LSB and variable. So whatever the variable you want to declare, so that variable. Okay. So that means whatever the range is there, that will come before it will come. Size will come before. Okay. Suppose if you want to store, one second. Yeah. If you want to store the values, okay, suppose if you want to store the value 3 tick binary 011. Okay, if you want to store the value 3 tick binary 011. Okay, how to represent? So I am writing for this code module module suppose test. Okay, module test. I am declaring reg. How many bits are there? 3 bits are there, no? So this is the size is 3 bits and this is a binary value. So 2 down to 0. 2 down to 0 A. 2 down to 0 and initial and A equal to what? 3 tick binary 0 1 1. 3 tick binary 0 0 1 1 and end module like this we can declare. Okay, so that means in vectors you have indexing. What is the indexing? So you declared the binary value as what? 0 1 1, no? So this is the index 0, index 1 and index 2. Okay, so these are nothing but we call as indexes. Okay, so this is nothing but indexes. Okay, so like this grouping, so like this we can represent. Okay, suppose if you want to store four values. Okay, four binary values. So how you are writing? This is the standard representation. That means first reg. So it will start from what is the index? Let us take 4 bits: 0 1 2 3. Okay, so that is 3 down to 0, 3 down to 0 a, 3 down to 0 a. Okay, how it will store? So how it will store in the vectors means first, so here 4 bits, 4 locations will be formed: 0 1 2 3. Okay, 0, so first msb 0, so 1 1 1, like this it will store. Okay, so so suppose if you consider like 0 reg 0 down to 3 a. Okay, mostly we will not use this representation, we will not use. Okay, previously I told you, no, like msb down to lsb to msb we are not using, mainly we are using msb down to lsb. Okay, suppose if you want to store some 32-bit value, what I will declare? Reg 31 down to 0 b, 31 down to 0 b. Okay, so that means here it will form like 31 locations. Okay, so like this, this is 31 30 up to so on, it will store 0. Okay, like this it will store. Okay, so this is nothing but vector. Okay, suppose next I want to I want to store 5-bit value. Okay, so 6-bit value. So how will I will declare? Reg 5 down to 0 m, 5 down to 0 m. Okay, so 5 down to 0 m. So in this I want to store so total 6 values. Okay, 6 values will be formed: 0 1 1 0 1 uh, 0. Okay, so this is indexing 0 1 2 3 4 5. Okay, so like this I can store. So that means m equal to what? M equal to 6 tick binary this value: 0 1 1 0 1 0, like this I can store. Okay, so how we can? So next is vector slicing vector slicing. So what is this vector slicing? Suppose I will consider module TB, module TB. I am declaring reg 5 down to 0 m, 5 down to 0 m. Okay, and next I want to means I want to represent reg 1 down to 0 n. Okay, reg 1 down to 0 n. Okay, so initial m equal to, let us take a 6 tick binary 0 triple 1 and 0 1. Okay, 0 triple 1 0 1 and end module. Okay, so that means here total 6 bits are there. 6 bits. Okay, so 0 1 1 1 triple 1 0 1. Okay, so so suppose if I consider, like if I want to access only 2 bits. Okay, so like n equal to, so n I declared as 2 bits, no? N equal to m of 3 is to 2, I can access. Okay, so what is m of 3 is to 2? Indexing 0 1 2 3 4 and 5. Okay, these 2 bits I need to access. This is nothing but vector slicing. So now n becomes what? N equal to you will get 1 1. Okay, n equal to you will get a 2 tick binary 1 1 you will get. Okay, or I can access only one bit also. Suppose n equal to m of 5, m of 5. So that means I can access this bit also, only this bit. Okay, this bit. So that is n equal to what? 1 tick binary 0. So that means vector slicing is nothing but I can access any one of the bit. Okay, any number of bits. Okay, so either 2 bits or 3 bits. That is nothing but vector slicing. Okay, so combining means I can access individual bits in the vectors. That is nothing but vector slicing. Okay, hope you understood. Shall I move forward? Hello.
One question actually. So
Yeah.
if you're using little endian, right? So does the index change for the assigned numbers?
Little Indian actually it will not take. Yeah, indexing will change. Indexing Little Indian means what? I told you, no. Little Indian means what? LSB to MSB means first LSB will come. Okay, first LSB
Okay,
will come. After that MSB will come. Mostly this maybe this we are not using. Okay, mostly we will not use in the vectors. We will use the only MSB down to 0. MSB down to LSB only. The index will change. It will start from, if suppose if you consider LSB to MSB means it will start from where, suppose if you consider 4 bits, it will start from here. 1, 2, 3, 0, 1, 2, 3. This becomes LSB and this becomes MSB.
okay,
Okay, we will not
okay,
prefer, mostly we will not prefer, but indexing will also change. Okay, is it fine?
okay. Yeah,
Okay, yeah.
yeah, yeah. Okay.
Next, let us take, suppose, mm, yeah. Suppose if you consider module TB module TB and reg 1 down to 0 A comma B comma C. Okay. So this is what is the width? So what is the width? Width is so both A equal to 2 bits, B equal to 2 bits, and C is also equal to 2 bits. Okay. It will assign all are 2 bits only. Okay. And next TB module TB reg 1 down to 0 A. Okay. Suppose if I keep semicolon and here I will keep B. Okay. Here any error is there? I am asking any error is there in this? Waiting for your response.
I think no.
Some error is there. Suppose any statement it is means close with this semicolon. This is nothing but what? End of the statement. End of the statement. Okay. End of the statement. Here you declared, that means you B is declared, but data type is missing. No, you not declared any data type. Okay. So that means it will throw compilation error. It will throw compilation error. Okay. So compilation error. Okay. So like this. So that means this semicolon. So same in C language we are using each and every statement there is semicolon. No? Same like that in Verilog also we are using this semicolon. So semicolon is nothing but this is the end of the statement. End of the statement. Okay. End of the statement. Okay. Uh, and here also suppose I am declaring example module example input input a comma b, okay, and 1 down to 0 c, okay, semicolon. Okay, output output some 2 down to 0, 2 down to 0 sum, 2 down to 0 sum. Okay, here also compilation error. Here also, so we declaring the inputs and outputs within the bracket, no. So that means here this is the end of the statement. Here also you will get the compilation error. So normally you need to keep comma, you need to keep comma. Okay, so that means these are small things only, but interview wise means you will get confusion. Okay, so that interview will try to confuse you. These are small things. So this semicolon should not be used inside the bracket. Okay, whatever the semicolon is there, that should not be used inside the bracket, inside the bracket. Okay, inside the bracket. And one more thing, suppose I told you this reg and y data type are unsigned data type, no? Suppose if I consider reg 2 down to 0 a, 2 down to 0 a, and a equal to 6, a equal to 6. Okay, so like I want to declare this value. Okay, I want to declare this value. So internally how it will store, this is 3 bits. Suppose dollar display, I'll write dollar display, the value of a is percentage b comma a. Okay, and module, I am using module test and end module, end module. Okay, here semicolon should be not be there. Okay, for the end module semicolon is not there. So internally what it will store, can you guess and tell me?
110.
Yeah, a equal to, it will store 110. Okay, a it will store 110. Okay, one more snippet I will write. Suppose let us take module test2. I am declaring reg 2 down to 0 a, and reg 2 down to 0 b. I am giving a equal to 6 and a equal to b equal to -6. After displaying what is the value of a and what is the value of b. Suppose if I want to display dollar display the value of a is percentage b comma b is percentage b comma a b comma b, end module. I am writing in between initial begin also. I am using initial begin and yeah. What is the value of a and b? A is same thing only, so that is 110. The decimal is 6 only. I am asking about the b.
Same 110.
No, it will store like it will store in terms of a 2's complement form. Okay, if it is in a binary number, it will store in terms of 2's complement form. In digital, we have seen that the negative numbers are represented in 3 forms, that is sign magnitude, 1's complement and 2's complement. Okay, why it is storing 2's complement means for the sign magnitude and 1's complement, there are two representations for 0. For -0 plus 0, two representations are there. Okay, so compiler can't decide whether to store the -0 or plus 0. But for 2's complement, you have only one representation. So that's why it will store in terms of 2's complement. So what is the 2's complement for 110? First one's complement 001. Adding 1 to this, what you are getting 010. Okay. So that means here in terms of binary, it will store 010. But in terms of decimal, it will save, it will not display the negative number, it will display positive number only. So what are the binary representation of 010? 2 it will display. Why? Because, so the conclusion, what is the conclusion? So conclusion is, from this you can conclude that, so in Verilog we want to store the negative numbers inside the range data type. It will be converted into which form means 2's complement form. And so why it is 2's complement form means only one representation for 0. And conclusion you can write reg and net data type. Reg and net, or in net you are basically you are using wire data type. Wire are unsigned data types. Unsigned data types. Unsigned. Unsigned data type means what? Whether you are giving the like negative numbers, so normally it will store in terms of 2's complement. But when you want to display the 2's complement number, it will display in terms of positive number only. That is nothing but unsigned data type. Okay. Hope you understood. Any doubts or queries? Shall I move forward? Hello.
Yeah, you can go.
Yeah. Okay. Next is next. So what are the signed data types means? In the Verilog you have integer data type. Integer data type. So integer data type. So this integer data type is used to, where you are using means, this is used for counting or indexing. Okay, counting, indexing, or some general purpose calculations. We are using this integer data type. So so this is this is a signed data type. Signed data type. So when you are like in the previous code, when you declare this integer, so in the when you declare this as a integer data type, when you declare this integer data type, both integer b as integer and a as integer, now it will store, it will display in terms of decimal means it will display -6. Why? Because integer is a signed data type. Okay. So this is a signed data type. And what is the width or size? Width or size is so default width is 32 bit only, 32 bit. And default value, what is the default value? Default value is x. Default value is x. Okay. Suppose if I consider like if I declare integer a equal to 2. Okay, a equal to 2. Integer a equal to 2 means what? So so basically uh, so this will store like 32 bit. So it will store what is the binary representation for 2, 0, 1, and the remaining all are zeros only. Remaining all are zeros only. Like this it will store. Okay. So this is 31 and 0, 1, 2. Like this it will store. Okay. And we can't suppose if you want to access this a of 31, we can't access. Okay. Why we can't access means this is a packet data type. Packet data type. So what is packet data type? That means vector slicing is not possible. Okay, vector slicing. So okay, we cannot perform vector slicing in the integer data type. Okay, vector slicing not possible. Not possible. Okay, not possible. Suppose if I want to access integer, so from this I want to access integer 3 down to 0 a. Okay. So this is we can't use. Okay, that you need to remember. Okay, vector slicing is not possible. Okay. Yeah. Next. Next is so there are two types of declarations are there. Suppose module, module, example, reg a. A, you can assign the value a equal to 1 and you can write some piece of code and end module. Okay. This is one type of, that means we can declare the variable and assign the value. Okay, we can declare the variable, or assign the value. Okay, this is one representation. Let us take a style one. Okay, one type of representation. And next is we can declare the variable. Okay, so separately we can declare module. Let us take example 2. I will declare the variable with reg data type. Okay, and initial a equal to what, 1. Okay, so this is nothing but declaration, and next one is assigning the value, assigning the value. Okay, like this I can do. Okay, so there are two types of declarations are there. And next is float data type. So float data type, keyword is real. Okay, what is the keyword we are using? Real. Okay, this float data type is used for storing the fractional values, used for storing the fractional values, okay. And what is the size of this float data type? Means the default size is 64 bit. And what is the default value is x, and this is signed data type. Okay, signed data type. Okay, so this is about uh, float data type. So one more data type, the last data type is time data type. So time data type, this is used for tracking the simulation time. Used to track the simulation time. Okay, simulation time. And what is the size of this time data type? Means 64 bit, 64 bit, and default value is x. And this is unsigned data. Time is not signed. This is unsigned data type. Unsigned data type. Unsigned data. So how you are declaring dollar time, like this? You will declare. Okay. So these are the data types. And in the first class, I told you synthesis. What is synthesis? Can anyone say? Synthesis. Synthesis. Synthesis is nothing but you are converting your,
HDL code into
yeah,
gate level.
HDL code into gate level netlist, to gate level netlist. Okay, gate level netlist, or we can call as a hardware also. We are converting into hardware. Okay, so that is nothing but synthesis. So what are the synthesizable constructs? Okay, so synthesizable constructs are nothing but what are synthesizable and what are non-synthesizable constructs. Okay, so synthesizable constructs. Synthesizable constructs are nothing but we can able to make our hardware. Okay, we can able to make make our hardware. Okay, our hardware, or we can call as gate level netlist. Gate level netlist. Okay, and non-synthesizable constructs. Non-synthesizable constructs. Non-synthesizable constructs are we can't convert into hardware. Okay, which are not able to make the hardware. Okay, so which are not able to make the hardware. Make the hardware. Okay, so in this data types, we already discussed so many data types. What are synthesizable constructs and what are non-synthesizable constructs? So we have the data types like wire. First we already seen WAND, var, and reg, vectors, vector, integer. These are synthesizable constructs. Okay, these are nothing but synthesizable constructs or synthesizable data types. Okay, and next float, or we can call as real, float or real, and time, mostly time we are using the test bench only. We are not using in the design. Okay, so these are non-synthesizable constructs. Non-synthesizable constructs. Is it fine? Should I move forward?
Yes.
Yeah. Okay. So means these are some interview questions they will ask, and next we'll start with arrays. Arrays. Okay. What are these arrays? Okay. So what is the difference between this vector and array? Okay, so vector, so in the vector, so first we will see the difference between vector and array. Vectors, okay, so vector, the size is declared before the variable, before the variable. Okay, that is vector. Okay, what is an array? Array array is the size. Array, the size is declared in array, and the size is declared. Okay, the size is declared after the variable, after the variable. Okay, size is declared after the variable. Suppose like if you see the example, like let us answer reg 1 down to 0 a, 1 down to 0 a. Okay, so this is nothing but what? This is size. We already seen this is size. Okay, so this is size, and this is nothing but what? Vector. Okay, array means like reg a, first variable 1 down to 0, 1 down to 0. Okay, so this is nothing but array. Okay, suppose if you see the example for vector reg 2 down to 0 a, 2 down to 0 a, some a equal to, let us take 3 tick binary. This is 3 bits, no? 0 1 1. Okay, so like this I can consider. Okay, array means example for array, reg a 2 down to 0. Okay, reg a 2 down to 0. So normally if you are considering this vector, it will store like this horizontally, it will store. Okay, there is a index we already discussed, 0 1 2. Okay, so that means 0 1 1 it will store. So first lsb msb down to lsb, no? So first lsb will store, after that like that msb will store. And same thing if I consider three locations are there, and here a equal to 3 tick binary, 0 1 1 means it will store vertically. Okay, so this is the location 0 and location 1 2. Okay, so like this 1 1 0 it will store. Okay, like this it will store. Okay, storing the values inside the array we need to use indexing. Okay, for storing this we need to use indexing. For this what you are using, not this one, we need to use the indexing. Okay, one second. How we are storing these values means, so for arrays I can declare like that. One second. So here I am using two locations, no? So initial, so here for the arrays, I am writing the code. Reg a 2 down to 0. Okay, initial, begin. A of 0 equal to what? 2. Okay, let us take two bits only, 1 down to 0. A of 1 equal to 3. I need to use this indexing. Okay, and okay, so that means here like two locations will form. So this is 0th index and first index. In 0th index I need to store 2, and first index I need to store 3. Like this I will store the in the arrays. Is it fine?
Yes.
Okay. Suppose if I consider test module test reg a 2 down to 0, 2 down to 0. Okay, 2 down to 0. So this is the data type, and this is the variable, and this is the size. This is the size. Okay, I am using begin begin a of 0 equal to 5. Okay, and uh, so here a of 1 equal to 9, and a of 2 equal to 3. Okay, end and end module. Okay, so in the array how it will store means, reg is a 1 bit now. So reg is a 1 bit means you are using array. So you are using array. So that means here this is 0th index, this is first index, and this is second index. Okay, so normally it will be converted into 5 means what? Normally it will be converted into 101 binary. Okay, 9 means 1001, and 3 means 011. Okay, so whatever the LSB bit is there, that will be stored into A. Here 1 will be stored, and here also 1 will be stored, and here also this one will be stored. Okay, here also it will be stored in terms of binary only, not two. Binary of this is how many bit? 2 bits, no? This is 1 0 and this is 1 1. Okay, this 0 will be stored. Okay, sorry, not 2, 0 will be stored, and this 1 means 1 will be stored. Okay, so like this it will store whatever the, as reg is 1 bit, 1 bit data type, so only 1 bit will be stored in the array. Okay, this whatever the LSB, least significant bit is there, that will be stored. LSB bit, that will be stored. Is it fine? Suppose if I want to store 2 bits. Okay, module test reg 1 down to 0, a 1 down to 0. Okay, so that means here this is nothing but vector. Size is declared before the variable is nothing but vector, and this is dimension after the variable is nothing but array. Okay, whatever the dimension after the variable, that is nothing but array. This decides the number of locations. How many number of locations? How many number of locations are there? Two locations are there. Okay, so two locations are there means here. So that means how it will create means, here like two locations are there. This is index 0 and index 1. Each location has how many bits? 2 bits. Why? Because you declared the vector, no? Okay, so that means there are two locations. These are nothing but two locations. Okay, two locations. In these two locations, how many bits we can store means 2 bits. 2 bits we can store. Okay. So like this, we can develop the memory also. Suppose with the help of this arrays and vectors, suppose reg 7 down to 0, mem of 31 down to 0, 31 down to 0. Okay. So this is nothing but these are nothing but number of locations. Okay, number of locations, and this is nothing but total. This is nothing but depth. Depth is how much total. 32 locations are there. 0, 1 up to so on. 31. 31 total 31 locations are there, and this is nothing but we call as depth. When we discuss the RAM, this is nothing but depth, and width. This is nothing but width of the RAM. Okay, so width is how many bits total? You have 7 bits. Okay, 0 to 8 bits, 0 to 7, 8 bits, 0 to 7, like this. Okay, suppose one second, one second, one second, one second. Yeah. So total locations, 2 locations. So depth is 31 location, and width is so width is how many? 7 locations. Suppose we'll take one example. Uh, is it fine how we are declaring the width and depth of the how to create the memory and all those things?
Yes.
Okay. Next, suppose if you consider test, module test, I am considering reg 7 down to 0, mem of 1 down to 0, mem of 1 down to 0. I am using begin, initial begin, mem of 0 equal to what? 8 tick binary 1001 underscore 0 triple one. Okay, 0 triple one. Okay, okay, and next, sorry, mem of 1 equal to 8 tick h 12. Okay, end add end module. Okay, so that means how many? So this is nothing but number of locations, and this is nothing but vector. That means each location how many number of bits I can accommodate. Okay, this is by using the vector. Okay, so that means you have total two locations. Two locations are there, 0 and 1. Okay, so 0 1 location, and so first location how many bits I can accommodate? 7 down to 0 means 8 bits. Okay, this is 1 0 0 0. Okay, 0 triple one. Okay, like this I can accommodate. And 12 means you convert into binary. So this is hexadecimal. So you know that hexadecimal how to convert into binary. Hexadecimal is radix is 16. You want to represent in 2 power 4. So that means each value represented in 4 bits. Okay. So this is one means one second. One means this is 0001, and this is 0010. Okay. So 00101, and 0010. Like this it will store. Okay. So based on this program you can try like this it will store. Okay. And one more thing, module module test reg, let us take 2 down to 0, mem of 1 down to 0, initial, begin. Okay. So if multiple statements are there, you need to write between the initial, begin and block. Okay. So initial means procedural blocks. When you are using reg data type, you need to use procedural blocks, either initial or always. Okay. So mem of 0 equal to what? 2 tick binary 1 0. Mem of 1 equal to 2 tick binary 1 1. Okay. End and end module. End module. Okay. So how it will store? So that means so here how many locations? Two locations are there. This is number of locations. Okay, number of locations. So two locations are there. In this 0th location or first location, each location is 2 bits, and this is 1 and 0, and this is 1 and 1. Okay, these are nothing but contents in my memory location. Okay, contents are values in the memory location. Okay. Like vector slicing is not possible. Suppose if I want to access only one bit. Okay, vector slicing, so that means if you want to access this lsb bit. Okay, vector slicing, that the slicing vector slicing is not possible in the arrays. Okay. So vector slicing, so this you need to remember, vector slicing is available, means available in the vectors, but vector slicing is not possible in the arrays, that you need to remember. Okay. So this is about the data types and arrays. uh, One more so
Here there will be three locations, right? Reg 220, right?
one second. 1 down to 0, yeah. Three locations means, yeah, 1 down to 0. If you consider 1 down to 0, two locations only, no?
Okay.
1 down to 0, I'll put. Okay. Yeah, yeah. Next, I want to show you about this. I think Vivado you are using. Vivado, how to install the Vivado and all those things. I'll tell you some programs related to some EDA playground, simple programs. EDA playground, this is EDA playground open source. So this is the open source. So you need to create your account with your mail ID. Okay. So this is EDA playground. One second, I'm opening. So here you need to register with your mail ID. So I'm registering with my mail ID. Okay, you need to register. So already I registered. That's why I'm signing with my mail ID. So I'm logging in this. In this. It's taking time. It's taking time. In Vivado also you can do the program. Okay, just will wait for till I'm opening the Vivado. Xilinx Vivado. You can download that Xilinx Vivado. So in the Xilinx Vivado, first you need to just create one project. So you need to create a project that is new project. So you need to like uh, select the project location. Okay, and this is my project location. So you need to select one folder D drive, and in the D drive just to keep one Verilog codes. Okay, so I'm using. So you need to give some project name. Let us take. I'm giving the project name as data types. Okay, I'm giving the project name as data types. Okay, data types. So you need to keep next data types also there. Data type examples. I will keep examples. Okay, examples. Next, next. So this is the RTL project. Next, I need to create one source. So I am creating one test or example, whatever may be this test. Okay, uh, and next. This is optional only. Next, so finish. So my like my program is also module name is also test. I am creating. So this is my test. Okay, normally it will come. Just this one is not required. This one you can take it. And here I am writing the code. Suppose the test. So I am declaring reg A. Okay, and reg A, reg B. Okay, reg A, reg B, and initial begin initial begin. Okay, I told you, so when you are writing like uh, reg data, you are using reg data type, you need to write between the procedural blocks, that is either initial or always. Okay, begin. So I am considering b equal to a, and I'm displaying this. Okay, I'm displaying this, that is what is the value of a. So that means dollar display the value of a. The value of a is, let us take percentage d comma a. Okay, comma value of b. Okay, value of b is percentage b comma b, percentage b comma b. Okay, percentage b comma b, and end module. Okay, end module. Okay, so this code I wrote. Okay, this code I wrote. So can you expect the output of this code? Anyone? Vivado is still loading. Yeah, yeah. Here also I will execute. Yeah. Can anyone expect this the output of this code? Waiting for your response. Just I initialize reg A, reg B, initial begin B equal to A. So whatever the A value is there, I mean I initialize to B, and dollar display the value of B is percentage D comma B. And what is the value of B? I am checking. Can anyone, or shall I tell?
Is it X?
Yes, it's X only. Why? Because the default value for reg data type is X only. So go to run simulation, run behavioral simulation, save this project, behavioral simulation, run behavioral simulation, and you can see the output in the TCL console. So here you got the value of A is X. Okay. So this code, the value of A is X, and I can see the waveform in the this simulation part also. So this one I need to execute in the EDA playground. How to execute? Just the same code, copy this code. The Vivado, this EDA is open. Here, whatever the code you are writing, that you need to write in the design. That is this one. And whatever the test bench is there, here you need to write. Okay. So now I am not writing the test bench. I am writing the design only. Just to copy this code and go to languages. So select either it can be system Verilog or Verilog. Okay, and next tools and simulators. Go to tools and simulators. Select Aldec Rivera. Okay, first part, that is Aldec Rivera, and just run this code. Okay, run this code. The value of b is x, like this. The value of b is x. Okay, so like this you can see the see the output of any code. Okay, you need find how we are writing the code and how we are executing in Vivado as well as in the in the Vivado and EDA playground.
Yeah, it's clear.
Okay. Yeah. So like this, whatever the examples I told, I will share one more assignment also related to this data types. Just try to this execute in EDA playground and Vivado, and so open this EDA playground and create your create register with your mail ID, and yeah, you can select this language Aldec, this system Verilog or Verilog, and the tools and simulators as Aldec Rivera. If it is a Vivado 25, this is nothing but Vivado 25 is there. So if you want, I will share one link also how to install this one. So you can install this. This is open source only. AMD Xilinx Vivado. So for simulation part, you need to go to run and run simulation. And here, suppose if I want to write one more, suppose I'm writing one more code, same code I'm writing. Okay. So go to sources, click on sources, add sources. Okay. Create the file. I'm creating test one. Okay. Test